Alright everyone, so I'll post the video or these notes to the internet on our site, but I just wanted to show you that we have these formulas right here. These are our multiple angles, or sometimes they call them double angles since all these values are 2. And there is something special that we can see here. We can use this tangent formula, but something that's more useful in this problem is we can actually use sine of 2u and cosine of 2u and divide those two answers to get tangent of 2u as well. So we'll show you that in a few examples. And also, again, I'll post these notes online. Long story short, you can use these identities to solve trig equations. So right here, we have a cosine 2x, and we can use one of the multiple angle formulas for cosine to then get that quadratic shape and solve. And you'll see something similar with a sine of 2x problem that looks something like this online. But with that being said, I'm going to open up your MyOpenMath, and we're going to work through some assignments. Hello. All right. So we have this question right here. It says if sine of A is negative 3/5 and A is an angle in quadrant 3, then find sine of 2A. So here's what we're going to do for that. We're going to draw our triangle in quadrant 3. Make sure you go left to right, then up or down, and connect back. And that means angle A is closest to the origin, and since we know sine, we know the opposite is 3 and the hypotenuse is 5, and the 3 should be negative since it's moving down. And also, one thing we might want to note for ourselves is that whatever we solve for right here, that's going to be negative as well. Also, going quickly, when you do the Pythagorean theorem to find this missing side, you'll do 3 squared plus something squared equals 5 squared, and you'll end up getting 4. And again, it's negative 4 because it's moving left. So what does the sine of 2a formula say? Well, it says if you want sine of 2a, you just need to find 2 times sine of a. And sine of a we already knew. It was negative 3/5. And cosine of a I'm now able to find. It's negative 4/5. And when you multiply all that out, just remember that 2 is really over 1. So we have 2 times negative 3 times negative 4. And that will end up being 24. And 5 times 5 is 25. There's also a 1, but that doesn't really matter. So 24 over 25 is our answer. Yay. And let's keep on going through. Up next, we've got some wilder numbers, but we're given a cosine value. And that cosine value is in quadrant 2. So in quadrant 2, I move left and up and connect back. I'm given A, and let's see here, I get adjacent is 9, and hypotenuse is 41, and this is negative. And when you do the Pythagorean theorem this time, I'm pretty sure, let me see here, we're going to get 41 squared minus 81, or in other words, 9 squared. I get that value, and if I square root, I get 40. Now 40 should be positive because it's moving up. So for cosine of 2 theta, so we do get choices. And so for me, I think the easiest formula to use is the cosine squared formula minus sine squared formula. And I think you'll see why that's true, but we'll do another one just to show you that you do get the same answer. Now cosine of this triangle, again, we already had that. It was negative 9 over 41. And we could square that. Minus sine squared, well, we just found that. That's 40 over 41. Square that. So when we square negative 9, we do get 81. When we square 41, it looks like we get 1681. When we subtract that from 40 squared, that's going to be 1600 over 1681. So 81 minus 1600, let's find out what that is. So it looks like we get negative 1519 over 1681. And I'll just kind of click this answer button. There we go. That's our correct answer. All right, and maybe let's look at a tangent question, and we might be out of time. Now, when you look at this tangent question, this is a different way of saying our angle is in quadrant 4. Hopefully you can see that, and I'll kind of use this picture right here. If this is where 3 pi over 2 is, which it is, and this is where 2 pi is, and you're in between, that's just another way of saying you're in the 4th quadrant, all right, just so you know. So this time, well, actually we're not doing a tangent question, but I guess we'll move on from that. Let's do a tangent question. Did I ask you a tangent question? Yes, I did. Here we go. So this one, they told you that tangent was 2. And let me just look at our tangent formula again one more time here. The good thing about your tangent formula is you only need tangent here, but you're going to have a bunch of wacky fractions. So I'm going to go through this 2 ways. I'm going to go through this doing, oh, you know what, I was supposed to do it with the cosine formula too, but yeah, why not? We'll do the cosine formula the other way. So let's say you wanted to use the cosine formula where it was 2 cosine squared minus 1. Now, why might you want to do that? Because on that last question, you actually already had cosine, which means you could do the formula right now without needing to build the triangle at all. So that's actually pretty significant there. But we could do 2 times, well, when we square this, we've seen this, we get 81 over 1681 minus 1. When we multiply that by 2 over 1, we get 161 minus 1681. Now, when we have this minus 1, we're going to turn that into something with the same denominator. We're going to have 1 be 1681 over 1681 so that we have common denominators. And last but not least, when you do 161 minus 1681, evidently you'll get 1519. So likewise, let's look at our tangent question here. Our tangent question, we were given a tangent value, so let's just start plugging that in. We have 2 times 2, because that is what tangent of theta is. Then we have 1 minus tangent, which is 2 squared. So that's going to be 4 over 1 minus 4, and that's going to be 4 over negative 3. Or negative 3 over 4. I think it'll work either way. Let's find out. Yes, it will. I wonder if they don't ever give you tangent. They do give you tangent. Well, I'm going to make up a problem right here real quick, and I'm going to have you solve for tangent as well with given sine. So let's do this. We have our sine value. And sine, if we read that as in quadrant 2. So we have the opposite 5 over the hypotenuse 13, and we can Pythagorean theorem solve and get negative 12. Now, again, I'm going to find tangent. Actually, you know what? I'm going to find sine, cosine, and tangent. So sine of 2 theta would be 2 times sine, which is 5 over 13, times cosine, which is negative 12 over 13. When you solve that, that's going to end up being negative 120 over 169. Now, if I wanted to do cosine 2 theta, again, here's one thing that's significant. Yes, you could do the sine squared and cosine squared formula, but since you already know sine, you could just use the 1 minus 2 sine squared formula because you already know sine, so you don't need to do any more work. That will be 1 minus 2 times 25 over 169. That will be 1 minus 50 over 169. And that will end up being, let's see here, 119 over 169. So that's cosine of 2 theta. Again, you could try it with another formula and verify that. Let's look at tangent of 2 theta. So I can now look at this triangle and find tangent. Tangent's going to be 5 over 12. So tangent says 2 times your tangent value, negative 5 over 12, over 1 minus negative 5 over 12 squared. Now this is where tangent formulas get really, really nasty. We end up getting, it looks like negative, we can reduce this. We will get negative 10 over 12, but that reduces to negative 5 over 6. And I'm going to then put that over 1 minus, now this will square and become positive 25 over 144. But I still have 1 minus this fraction, so I'm going to change 1 into 144 over 144. So I have negative 5 over 6. And 144 minus 25 is, looks like 119 over 144. And my last step here is to divide these two fractions. So I really have negative 5/6 divided by this bottom fraction. So in other words, I have negative 5/6 multiplied by the reciprocal. And let's use a calculator to finish that off. So negative 5 over 6 times 144 over 119. And we can press math fraction on that. And I got negative 120 over 119. Now, when you're done with your tangent problem, if you have to find the other two along the way, let's maybe look at this. Take a look at what sine was, take a look at what cosine was, and now look at what tangent is, and that is definitely significant for a reason. If you notice, if we had just taken our sine of 2 theta and divided it by cosine of 2 theta, well then we would have kept, changed, and flipped 19, and our 169s would have canceled out, and we also get the same answer, but kind of easier in my mind. So if you can find tangent of 2 theta and cosine of 2 theta, which does take a little bit of time, you can avoid some of this crazy fraction work later, but I guess either way fractions are in the problems. But good luck, and I miss you all, and I hope your day is great.